Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morals Math Corner. Today we're going to learn how to divide monomials. So let's get right to it. All right, we're going to first learn about the quotient rule. And the quotient rule for exponents states that when you divide the same base, in this particular case A, you're going to go ahead and keep that same base and subtract the exponents. So I'll repeat that. Whenever you divide the same base, you go ahead and keep the base and subtract the exponents. And also, if you have something inside of a parenthesis, some sort of operations as far as a monomial is concerned, just like in the product rule, whenever you raise a power to a power, you multiply that exponent to all of the powers inside of the parentheses. Same thing here, but this time you have a fraction inside of there. So you have a to the first power and b to the first power all raised to the n power. So again, whenever you raise a power to a power, you're going to go ahead and distribute or multiply that outside exponent to every exponent inside, rendering you with a to the n divided by b to the n. So let's just give you a quick example. If I have x to the 8th power divided by x to the 3rd, this is going to give me x to the 8 minus 3, which equals x to the 5th power. All right. If I have, for example, let's say 2x over y squared to the 3rd power, this is going to give me 2 to the 3rd power times x to the 3rd power over y to the 6th power, because I distributed that outside 3 to all of the exponents inside. All right, let's talk about the rule for negative or integer exponents, okay? Whenever you have an exponent that is negative, you're not going to really want to work with that. You're going to want to make it positive. And in fact, whenever you're working with these questions, they're always going to ask for the answer with positive exponents. So let's remember that rule of the invisible one. When I have a to the negative m power, that's in the numerator. If I go ahead and simply move that to the denominator, I go ahead and change the power of the exponent. Okay, so that's all you got to do. And if I have that negative exponent in the denominator, like in this example that I'm circling here with blue, that's 1 over a to the m power. So I'm going to go ahead and move that back to the numerator, and again, it changes the sign. So if I have a negative exponent in the numerator, I go ahead and bring it down to the denominator to make it positive. And if I have a negative exponent in the denominator, I go ahead and move it to the numerator to make it positive. A nice trick here, this is a good one, so you may want to really pay attention to this. If I have a negative exponent on the outside of my monomial, okay, I can go ahead and literally flip the inside parts of the monomial, and I change the sign of that exponent. So I literally just reciprocate what's inside of that exponent. Let me give you a couple examples. Okay, if I have, for example, 2 to the negative 3rd power, that's going to equal 1 over 2 to the 3rd power. If I have 1 over x to the negative 5th power, that's going to equal x to the 5th over the 1st power. Again, I just brought the negative exponent down to make it positive, and in the next example, I brought the negative exponent up to make it positive. And if I have, let's say, 2x over y to the negative 3rd power, I can go ahead and just reciprocate the inside part of that monomial, and look at what happens. That negative exponent becomes positive. And then from there, I can go ahead and distribute that exponent, and it will give me y to the 3rd over 2 cubed, which is 8x cubed. All right. And the definition of zero exponent. Anytime I have any anything, any term, rather, not anything, any term raised to the 0 power, it's going to go ahead and equal 1. So 2x to the 0 power, that equals 1. But if I have 2x to the 0 power, that equals 2. Why? Please try to remember that that exponent affects directly to the left of it. And in the case above, remember it's in a parenthesis, so it affects everything. All right, let's get to some examples here. All right, let's simplify each expression. I have 6 to the 8th divided by 6 to the 3rd. I'm dividing the same base, so I'm going to keep the base and subtract the exponents. So that's going to give me 6 to the 5th power. And then I can always use my trusty calculator to raise 6 to the 5th power, and that will equal 7,776. All right. 25x to the 3rd divided by 15x to the 9th. Well, I can reduce the 25 by 5, so 5 goes into 25 5 times, and it goes into 15 3 times. So that's 5/3. And then I have x to the 3rd divided by x to the 9th. So that's x to the 3 minus 9, which equals 5/3 x to the negative 6th power. But please notice that you have a negative exponent. So I've got to bring that down to make it positive. So this is really going to equal 5 over 3x to the 6th power. Please take a second to understand what you just did there. Okay? You went ahead and reduced the 25/15. Excellent. Then you brought that 9 up, right? Because it's 3 minus 9. You're dividing the same base. You got to subtract the exponents. That gave you negative 6 as an exponent. And then I had to bring that exponent down to make it positive. Okay? Now that is the absolute technical way to do it. But I want to modify it here for you. So let me show you what I do, and I think it's a lot easier. First of all, of course, I'm going to go ahead and reduce. That's a no-brainer. However, instead of doing that whole subtraction thing and then moving it down, this is what I see. Aren't there 3 x's up here in the numerator? And aren't there 9 x's down here in the denominator? Guys, let's just cross-reduce kind of thing. Can't I get rid of, if I get rid of 3 x's from here and 3 x's from here, aren't I left with 6 x's down there? Done. It's a lot quicker. You may not like it. You may not see it. It may take time for you to get used to that. You could go either way. All right? That's why this is a video. You could rewind and watch it again and pick the way you like. So again, this is going to be 5/3 x to the 6th power. Okay, 3x squared to the 0. Notice that everything here inside of the parentheses is being affected by 0, so that equals 1. All right, fractions, not the friend of many people, but let's try not to be worried about this. First of all, I like to put a 1 in the denominator, so that way I can differentiate between numerator and denominator. Let's go ahead and cross-reduce here. 2 goes into negative 12, negative 6 times. 3 times negative 6 is negative 18. You can do that any way you want, okay? Sometimes people don't like that. You could do 3 times negative 12, that's negative 36. Divided by 2, it's negative 18 as well. Any way you want to slice that apple, it's fine. So now I have a to the 3rd times a to the negative 4th. That's a to the negative 1. Because when I multiply the same base, I add the exponents. Then b to the negative 2 times b to the 5th power. That's b to the 3rd power because when I multiply the same base, I add the exponents. Then I have an a to the negative 1, which I got to make positive. So that's negative 18, b cubed. And then I'm going to bring that a to the negative 1 down to the denominator, making it positive. And I am done. See, not that bad. All right. Negative 2y squared over z cubed x to the 2nd power. All right, so I'm going to go ahead and take that outside exponent and distribute it to every exponent inside here. Please remember there's the invisible exponent here and here of 1. So I've got negative 2 squared, y to the 4th, z to the 6th, and x squared. So then this is going to be 4y to the 4th over z to the 6th, x squared. There aren't any like variables that I can simplify, so we're done. 5 times y to the 0 power. Please note, the y is affecting, the 0 is affecting the y, not the 5. So this is 5 times y to the 1st is 1, which equals 5. All right. Hopefully we're flowing with this. 2 to the negative 3rd power. Well, I'm going to go ahead and bring that down. So that's going to be 1 over 2 to the 3rd power, which is 1/8. B, negative 2 to the 3rd power. This negative 3 exponent is affecting the 2, not the negative 1. So this is negative 1 over 2 to the 3rd power, and that equals negative 1 over 8. Please notice that the negative, the integer, negative 1, does not get brought down to become positive. It's the exponent that can be made positive or negative by bringing it up or down to the numerator and denominator. Okay, this one seems to always baffle people. 4 to the negative 1, don't stress that. That's just 1 over 4. Plus 2 to the negative 3rd is 1 over 2 to the 3rd power. So that's 1/4 plus 1/8. Common denominator is 8, so I multiply the denominator by 2, the numerator by 2, and that's going to give me 3/8. I have negative y to the negative 5th power. So everything inside of this parentheses is getting affected. So this is going to be 1 over negative y to the 5th power. And remember that whenever you're raising a negative to an odd power, it stays negative. So this is going to be negative 1 y to the 5th power. This negative, I like to always keep in the numerator myself. So let's go ahead and bring that up there. It's a good habit to get into. Okay, I have negative 4x to the 4th over 3 raised to the negative 3 power. You can distribute this negative and have a little bit of a mess on your hands, or you can go ahead and remember, hey, wait a second. If I reciprocate the inside, the sign of the exponent changes to a positive. So now it's a lot easier. So now I have negative 3 to the 3rd power over 4 to the 3rd power times x to the 12th power. So that's going to give me negative 27 over 64 x to the 12th. Let's go. Woohoo! All right, the piece de resistance, last one. All right, we're going to multiply here. So first things first, don't let the negative scare you guys. A negative 1 times a negative 1 is positive. So that's it. That's done. 2 divided by 2, done. Those cancel. And 5 goes into 15 3 times. Oh, not 5, 3 times. All right, so what do we have? That mess, all of that becomes 3. Now, m to the negative 2 times m to the 1st power is m to the negative 1. And then n to the negative 1 times n to the 0 is n to the negative 1. I want to make those exponents positive, so this is going to become 3 over mn. And we are done. Hope that helped out. Hope you learned a lot. Thanks for watching. Come back to Morrow's Math Corner anytime. Take care now. Bye-bye.